So our lecture today is on parametric equations. Shh. Most functions, as you guys know, are functions of x. So like y is a function of x. But the difference is that for parametric equations, now we're introducing a third variable called a parameter. And instead of y being a function of x, now x and y are both functions of this third variable called the parameter. Oh, shoot. I just realized they handed me a slip. I didn't. Um, so as you guys can guess, t is usually time. So we're typically thinking about how two variables are varying with time. Um, but the parameter doesn't matter in terms of what it's named. We can do an example. I'll show you guys how this works. So suppose we had a parametric or a set of parametric equations like x equals 3t plus 2 and y equals 5t minus 3, something like that. So we can try plotting this. And the way to plot this is just by plugging in different values of t and then determining what the coordinate that we get out. So for instance, if we plugged in t equals 0, we would get x comma y would be 2 comma negative 3. And so our point would be here for t equals 0, right? So this point here corresponds to t equals 0. That's because when we plug in t equals 0, we get 2 comma negative 3. If we plugged in t equals 1, then we would get 5 comma 2. So that's like here, 5 comma 2. And this is t equals 1. If we plugged in t equals negative 1, we would get negative 1 comma negative 8. And so that's somewhere here. Negative 1 comma negative 8. And this is t equals negative 1. And as you guys can see, as we are changing t around, we ultimately are getting a line. And so you can think about it, as t is increasing, the point x comma y is just moving along in this line. And so we would say that this parametric equation describes a line. Questions? Too easy? Too hard?
Wait, did you think the homework check with the quizzes wasn't a good idea?
I thought it was okay.
Now what's this then?
It's your homework?
Go back to signing regular homework.
No, we're doing the same format. Yeah, I don't know if it's improved you guys in any way, but at least it's not worse. So, and I don't like WebAssign. So I think it's more helpful that you guys get the homework with the full solutions. It's easier to study from. Yeah. Any questions about the line? Then let me talk about how we can convert a parametric equation into a what we call rectangular equation, which is just a normal equation with x and y. So to do that we do something called eliminating the variable. That's even called that. It's just what we do. So if we have, so I'm just doing the same exact set of equations, 3t plus 2 and 5t minus 3. In order to get this into a normal equation, what we do is we first isolate t from this equation and then take that value of t and plug it into the second equation. So it's pretty much like we're solving. So if we were to isolate t from the first equation, we would subtract 2 from both sides, and then we would get t equals 1/3 x minus 2. Correct? And then we just plug in that value of t into the second equation, which would yield 5 times 1/3 times x minus 2 minus 3. And so y equals 5/3 x minus 13 over 3 or something. And that would be our rectangular equation. Okay, and indeed, we have a line, right? So that confirms the graph that we just created. This is a line with slope 5/3 and y-intercept -13/3. Okay, so there are two ways of graphing it. You can either first take the parametric equation and just plug in different values of t and then just connect the dots, or you can first convert it into a normal equation and then infer how the graph should look like based on that equation. Any questions? We can do question 1, I guess. 1A. Yes, yes. Who's absent today? We're on. Jeffrey move. Yeah. Yeah, no. There's the bio honors field trip, right? Sophie, you're not in bio honors? I see. I forgot if my school had bio honors or regular bio. I know physics, we had a Great America field trip every year. We were supposed to study the roller coasters using physics, but none of us did that. Just played. Yes. Both?
No, that's crazy.
Oh, yeah. I know exactly. Yeah.
Bro, no way.
Presentation and, what the classroom and sounds.
Who passed out the classwork?
Wow, so unheard of. It's my favorite. Like a-
At least you're not. Yeah. You're recording, right?
Thought I did.
That's kind of how you.
Okay, are we done? Let me continue.
We solved the.
I did get. Yeah. That's not possible. Wait, what? Oh, you're actually.
Add two.
Okay, let me read it. Okay. Yeah. I'm gonna have to edit. I think I just want to have that. Yeah. No, it's not. It's right there.
Okay, are we done?
Oh, no, you were doing +1.
I don't know. Should be similar to what I just got. I think only this number is different. So
Wait, I got the exact same.
Really?
For that, it's supposed to be plus a minus 9/3, which is 3, because it's because if it's 10/3 minus 3, or like
Yeah.
yeah.
Oops. Yes.
Okay, dude, I was so confused.
Okay, are we finished?
No, 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 no,
Huh?
no, no, nobody.
Okay, let me do another example similar to B. So you guys might notice there's a sentence in the instructions. It says adjust the domain if necessary. That's because sometimes now that we introduce a parameter, there are issues with the domain that we have to be very careful about. So I'll show you an example. So for instance, if we look at this thing here, we can see that there are going to be domain issues because this square root here, right? A square root can never be a negative number. And so therefore y is always going to be positive. And so that's going to suggest that we might run into some issues, that we have to restrict our graph to a certain domain. So let's try to, what's it called? Eliminate the parameter. We can do that by squaring the second equation. So we get y squared equals t minus 1, which means that t equals y squared plus 1, right? And then if we plug that into the first equation, we're going to get x equals 3y squared plus 3. And what kind of equation is this?
Square root equation.
It is a
Exponential.
parabola.
But no, it's
So do it.
Mr. Nye, how do you know whether to put X or Y? How do you know whether to put X or Y into the eliminate the T? How do you?
Both work. Yeah. Okay. So does anybody know where the vertex of this parabola is? It's a horizontal parabola, right? It's horizontal and it opens right, and the vertex should be at 3, 0. Correct? So, we might be tempted to just draw this as our parabola and be done with it. But unfortunately, that would be wrong because y must be a non-negative number, right? Because the square root of anything is always going to be a positive number. We always choose the positive number. And so that means that this graph is actually not correct, and we only want to have the top portion of it. So that'll be the answer. Okay, that's because y has to be a positive number, and therefore we're only going to keep the top portion of the graph. It's a square root graph. Any questions? Well, you can do the one on the paper. And then I will talk about the trig ones shortly.
How did you find the vertex again?
There's the formula, right? I don't remember it, actually. Y minus k equals 4p times x minus h squared, something. Y minus k squared times 4 equals 4p x minus h. Okay, so I graphed it by using the formula that we learned, which is y squared equals, so if we convert this to the formula, we would have 1/3 x minus 3, right? And so you can graph it like that, and then this tells you that it's a horizontal parabola with a vertex 3, 0 facing right. No. Vertex 3, 0. faces right. No? Oh, you're talking about the classwork? Okay.
Yeah.
This is not. We asked for like rough drafting or was it more like?
I'm debating what to ask for. My one AI said, "Oh, just sketch it and it's fine," and then they just literally just scribbled whatever they wanted. It's not acceptable, and I'm thinking about tightening up my graphing policies. My pre-calc teacher, even if your lines weren't straight, she would take off points. We had to use rulers. And she said that when you showed your work, if every problem was not separated by a straight line, then you would lose points.
Feels like.
I don't know. Huh?
It feels kind of squishy.
Would take off saying.
Yes. You had to use a ruler to separate every question with a line.
But like they were all these things. And to do our homework. There. It was so, and so different. I know. And when I came to Valley, it's better, so I was still doing that.
Mine doesn't, because I guess most of one half.
And now my stuff is so. I read my first deadline on like stuff I'm doing at home, and I catch myself doing like, no one's gonna think this about me. It's on my computer, like, no one's gonna see this. See, it's my drive, like,
Okay, are we done?
To maintain the same.
All right, let's continue. Talk about sine and cosines. So, let's say we had a parametric equation with sines and cosines. How should we eliminate the parameter? Well, actually, let's first by trying to graph this. So let's plug in different values of theta. Now the parameter is not t anymore, but it's theta, so it's a little different. Let's plug in different values of theta and see what the graph looks like. Any guesses for what the graph is?
Oh, wait, you're right. It is.
No guesses?
Ellipse.
Good, very good, Liam. Okay, so what's the coordinate when we plug in theta equals 0?
It was 0?
No.
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 5.
Good, 0, 5. It's 0, 5 because sine 0 is 0 and cosine 0 is 1. Should have that memorized. So theta equals 0 is there. Okay, what if theta equals pi over 2?
Um, 3,0.
Good. Impressive, actually. 3,0.
Wait, dude, let's see. That's what you remind me.
Yeah, it's extreme.
Okay, theta equals pi.
It's
6, 7.
what's it? It's 0, -5, right?
Good.
Yeah.
Well, let's go with fire.
And then
Holy cow.
-3, 0.
Okay, last one is theta equals 3 pi over 2, and that would give us -3, 0. Okay, you guys need to know your trig functions like the back of your hand at this point. I don't have time to go over this. And so if you connect the points together, we get an ellipse, right? We're plugging in theta equals 3 pi over 2. So sine 3 pi over 2 is -1. And cosine 3 pi over 2 is 0. So that's -3 and 5.
How did you know to do that?
You just plug in useful values of theta.
Okay, so you always do pi over 2, pi.
Those give you the most graphable values of sine and cosine, right? So that's why we choose those. Like, do you know where 3 root 3 over 2 is?
3 over 2.
Yeah, so
That is
you don't want to graph that,
obviously,
right?
yeah, root 3 over 2. They pi over.
Yeah, it's about 2.5, but you guys wouldn't know that. So you guys need to plug in more useful values of theta. Okay, so we know it's an ellipse, but how can we do that by eliminating the parameter? The answer is that we have to use trig identities. So you guys need to have these trig identities memorized. Thankfully, you already do. So sine squared plus cosine squared is 1. 1 plus tangent squared. What?
Can you go back to the last unit?
1 plus tangent squared equals secant squared. And 1 plus cotangent squared is cosecant squared. Okay, we have these memorized. If you don't have them memorized, write them down right now. And so,
Write down stuff, like don't scroll so fast every single time.
and so, let's take the equations we were just given. So that's x equals 3 sine theta and y equals 5 cosine theta, right? Okay, so let's try to isolate, instead of isolating theta, let's just isolate sine and cosine and plug them into the identity. Okay, so sine theta equals x over 3, right? And cosine theta equals y over 5. And so if we just plug that in to sine squared plus cosine squared equals 1, which we know has to be true, what we're just going to get is x squared over 3 squared plus y squared over 5 squared equals 1, which is an ellipse. Right? Easy. This is an ellipse with semi-minor axis 3 and semi-major 5. Centered at the origin, 0, 0.
So they're values in. We just do this.
I was just demonstrating that it's an ellipse. It's a demonstration. You don't have to do it. Yes, you have to graph it using some method, either by plugging in values of theta or by just getting the equation first and then deducing that it's an ellipse. Okay, so that's how you do questions C and D. You have to isolate cosine and sine and then plug it in. Okay, so C and D are going to be ellipses. Can anybody guess what E and F are? Yes, hyperbolas, because you're going to have cotangent and cosecant, which are related by a minus sign. So that introduces a minus, which is why it's a hyperbola. But we'll do those later, since there's more subtleties there. You can do C and D in the next 3 minutes. I think this unit is not that bad. But pre-calc honors, apparently, to quote Mr. Nyberg, the test was a bloodbath. Yeah, but
Sounds fun.
this class is easier, so. Mhm.
Single good thing about like any of the tests is ever since you. Yeah. So yeah.
That's why they say Calc BC is easier than pre-calc honors.
And honors. Great question. Oh, yeah, I'm like. That's why. Like the figuring out what
Popular equation.
X and Y.
Okay, so is the elliptical equation, is the elliptical formula equation a particular equation?
Yes.
Oh, you're so. How did I do that? You're such a. No, I tried to do that too, but I was like, no, not doing that. And then like cosine,
Okay, are we done?
Well, drag that's why I died.
You put side, you don't put zero, you put. So pi over two. Data and okay, cosine. Look at like the.
Okay, are we done? Yes? Um, you can just label like the length. That's fine. Like semi-minor, semi-major, and that's enough.
X and Y, right?
Luna, please. Luna, please. It's annoying, okay?
Okay, you want me to not do that? Sorry, I do.
Yes.
Yeah. Oh, it's fun, zero. Looks like a log of math, like inside the zero, right? And then so
Good.
like that would like this was like last units like phonics and
Yes.
like really. No. This is an equation, right?
All right, are we finished? Let's talk about questions E and F. So E and F are going to give us hyperbolas, but also there's an extra wrinkle, which is that theta is limited between a certain interval. Can anybody think about why it might be limited to a certain range or domain? Very good. That's because tangent and secant are both undefined when theta equals pi over 2 and negative pi over 2. Right? Tangent equals sine over cosine, and cosine equals 0 at pi over 2, which means that tangent will be undefined. And so we need to restrict theta to a certain range. And logically, you can think about this because a hyperbola has two branches, right? And so as theta crosses over the undefined part, it's going to hop over to the other branch. So there's a discontinuity. That's a big word that you'll see in calculus a lot. Okay, so let's think about how we can do this. Let's first eliminate the parameter. So we're going to eliminate tangent and secant and then relate it using a trig identity. So tangent theta equals x over 2 and secant theta equals y over 3. And then if we combine these, using 1 plus tangent squared equals secant squared, we would find that 1 plus x squared over 4 equals y squared over 9. Right? And this is just a hyperbola because we can subtract the x squared from both sides. And we're left with this, which is a hyperbola that is vertical or horizontal. It is vertical. Very good. Because y is first, right? Okay, so we end up with a vertical hyperbola, and the vertices are going to be at, 0, comma, plus or minus 3, because this is our a value. We've done that a million times at this point. Okay, so we could graph the hyperbola, and if we graph the hyperbola, we would get something like this. Okay, would that be correct? It would not be correct. Because as we said, theta is limited between negative pi over 2 and pi over 2. So actually, we should only be getting, we need to think more carefully about how the domain is being restricted here and what that actually yields in a graph. So let's think about what theta means. If theta is between negative pi over 2 and pi over 2, that means that we're in these two quadrants, correct? And so in those two quadrants, what do we know about tangent and secant? Secant is 1 over cosine, right? But cosine in quadrants 1 and 4 is always positive, right? Because cosine is the x coordinate. And so therefore, cosine is always positive, which means secant is always positive, which means that y is always positive. Make sense? Tangent can be anything. It can be either positive or negative. So tangent goes through all real values, all real numbers. But y is specifically limited to positive numbers. Okay? In fact, y has to be greater than or equal to 3, because secant is always greater than or equal to 1, right? But you can just think about the signs, and because y is always positive, that means that we're only going to have the upper branch of the hyperbola. And so this would be our final answer. The upper branch in total. Yes. It does not go out of the range because y has to be positive, but x can be all real numbers because x is tangent. Any questions?
Wait, what? Never mind.
Any questions? Sure. So theta is in quadrants 1 and 4. Therefore, cosine is positive, which means that secant is positive. And then because y equals 3 secant theta, that means y is also positive. And if y is always positive, that means we only preserve the upper branch of the vertical hyperbola. Okay, so your answers in E and F should be 1/2 of the hyperbola, only one branch. And you have to think about which branch it is based on the theta that you're given. Any questions? You're given that in the question. Yeah. So this is the whole question. Okay, I will do G on the screen because frankly, you guys probably don't remember anything about logarithms. So just know how to do it for the homework and the homework check. Otherwise, you're free to do your work. Wait, I did it before on a different slide. I'm not going to redo it.